Hello everyone, myself Professor Gokul Patil. Welcome to our YouTube channel. In this session, we are going to discuss the algorithm and algorithm design tools. Now we will start first with the algorithm. Algorithm is nothing but set of instructions to solve a particular problem. We can also say that algorithm is a finite set of steps to be followed to solve a particular problem. The problem can be anything. Suppose we have to find out the largest number from the given number, or we have to find out the average score of the students for a particular test, or we can say we have to find out the result of the students. So consider a problem where we have to find out the score of the students in the 3 days marks. So we'll start with the algorithm for that particular problem. Step number 1. Let's start. Step number 2 is read the test marks. Let's say test 1, test 2 and test 3. These are the 3 tests we have to read from the user. Then we have to perform sum of that test. So sum is equal to T1 plus T2 plus T3. So we'll perform sum of that test marks. Then we'll find out the average of the given sum, average of the calculated sum. Then finally we'll print or display the average. Then we'll say the algorithm is terminated. So these are the certain steps for the problem to find out the average score of students in the given test. This algorithm has certain characteristics. So first we'll talk about the characteristics. The characteristics of algorithm. The first characteristics is the input. Every algorithm is having 0 or more number of input. In certain cases there may not be input, but each algorithm takes 0 or more input. 0 or 1 or 0 or more input. So for this algorithm, this is the input T1, T2, T3. That is the marks that we will have to read from the user. Second one is output. Each algorithm is an output. That may be, you can say, when we execute a certain statement, you will get a result. That result is nothing but an outcome. You can consider any function in C programming. When we write a function, there may be a parameter to the function or may not be a parameter, but that function will give a certain result. That is nothing but the output. Third one is definiteness. The definiteness is nothing but a very clear statement should be there in the algorithm. Statement should not be ambiguous. So if the statement is ambiguous, we cannot convert into the programming statement. So your statement should be very clear. Next one is finiteness. The finiteness means the algorithm should terminate after certain steps. So looking towards this algorithm, after this statement number 5, the algorithm is end. So there should be a finiteness in the algorithm. It should be terminated after certain execution of steps. Next one is effectiveness. The effectiveness means that a program is feasible or the algorithm is feasible. We can trace it using the pen and paper. In certain case, if I say there is a numbers A is 10, B is 0, and then I write a statement A by B, but B is 0, anything divided by 0 will give infinite. So when we execute this statement in program, we will get an error. So to trace it out that error, we have to write a certain way that should be reflected to the user. So that effective way we can write the program. So these are the important characteristics of the algorithm. For any algorithm, when you write an algorithm, consider these properties or characteristics so that you can able to write an algorithm. The next part is algorithm design tool. Algorithm design tool is flowchart. Algorithm design tools are flowchart and pseudocode. When you write the algorithm, that is a set of instruction for a given problem, then we'll write the programming statement to convert algorithm into program. So we will use flowchart and the pseudocode, two techniques in the algorithm design process. Flowchart is nothing but a diagrammatic representation to solve a given problem. There are certain symbols are there in the flowchart. So first we'll see the symbol and then we'll focus on the one of the problem. So the symbols are the start and the stop. We'll use this symbol. Start and stop, we'll use this symbol. We'll use a rectangle to represent statement, expression, we can use parallelogram for read, or we can say print. The next symbol is diamond, also called as a condition. Next symbol is connector, which will connect the algorithm. This is connector, and this is the line which will represent the relationship. So these are the important symbols in the flowchart. Now we'll see one example and to draw the flowchart with the help of the symbols. Suppose I want to find out sum of two numbers. So first we'll write the algorithm and then we'll convert that algorithm into flowchart. So algorithmic steps are start is the first step. Second is that first of all I have to write the two numbers, say number A and B. Then I perform the addition of that number by using one of the variable, let's say sum. Sum is equal to A plus B, and then finally I display the sum in the next step and then stop. So these are the algorithmic steps. Now we have to convert that step into flowchart. So the first step in the flowchart is it should be starting point. So it's a start. Then we'll have to read the numbers. To read the numbers, we have to use parallelogram. So here I read the two number A and B. Then there is a statement that I want to perform sum. So I use a rectangle. Sum is equal to A plus B. Then we have to print the result which is stored in the sum. So read and print, we have to use a parallelogram. So again I use parallelogram to display the result. Once it displays the sum, then we'll have to stop. So this is the symbol to stop the flowchart. So in this way, we can draw a flowchart from the algorithm. This is the first algorithm design tool. The next algorithm design tool is the pseudocode. Pseudocode is the logic of your program. So whatever the algorithm is given, for that algorithm, we are not going to write a complete code, but we'll write the logic of the algorithm, how it is going to be work. For example, we'll write the pseudocode for the same problem. I want to write the pseudocode. As I said, the pseudocode contains only logic. So here I write the pseudocode for this particular problem. So the pseudocode is, here I write a function, let's say void add, and let's say a comma b, a is equal to 5, b is equal to 5, and then I perform the sum, that is a plus b, and then I display this sum. So in this way we can write the pseudocode of the given problem. So hope you understand all these things, algorithm and algorithm design tool. To summarize this, algorithm is set of instructions to solve a certain problem, and there are certain characteristics of the algorithm, that is input, output, definiteness, finiteness and effectiveness. Then we discuss the algorithm design tool. In that, the two important things are there. One is flowchart, other is pseudocode. The flowchart is diagrammatic representation of the algorithm. There are certain symbols that we have to use to draw the flowchart. And pseudocode is the logic for a certain problem. So this is all about the algorithm. Hope you like this video. If you like this video, kindly share and subscribe the channel. Thank you.